Boiling water. Upon boiling water, the heat energy is supplied to the water and it boils till the temperature reaches the boiling point, i.e. 1000 C. At this temperature, the molecules break the intermolecular forces of attraction between the water and then the water turns into a vapor state. At this point, the vapor pressure becomes equal to the surrounding pressure and acquires saturated vapor pressure. Cooking food. You must have noticed the vaporization in the form of the tiny vapors. This is because the water added while cooking food reaches the boiling point of the water and the water starts converting into a vapor state. Evaporation. During the sun, the surface layers of the water get heated up and molecules present on the layer of water gain kinetic energy. Therefore, this energy is given out as these molecules with high energy succeed in breaking the bond and evaporate in the form of water vapors. As the vapor rises higher and higher, it gains more and more potential energy. Volcanic eruption. The molten magma is at high pressure under the depths, which when erupts and comes on the normal atmospheric pressure, the volatile matter is given off in the form of vapors. This is because the temperature of the magma is tremendous above the 1000 Kelvin, thus giving away the heat energy in the surrounding area. Pressure cooker. Inside the pressure cooker, the pressure felt is above 1 atm, and thus the boiling point of the liquids increases. As the temperature of a liquid rises above the boiling point, then the phase transition occurs and the vapor pressure thus developed is given out from the cooker lid. Steamer. The electrical steamers produce the steam as the water boils at the boiling point. At this temperature, the phase changes from liquid to the vapor and this steam flows out due to vapor pressure. Ice kept in a bucket. You must have noticed that the small droplets of vapor initially settle down on the container filled with ice cubes and then turns into the liquid drops. This is because the ice cubes grasp the heat energy from the surroundings and utilize it to break the molecular bonds to change the phase from solid to liquid. Hence we find the vapors settling on the outer surface of the container as the molecules condense due to the cool temperature. Alcoholic chemical. These chemicals are highly volatile liquids and can easily convert into vapors. That is why we can smell the alcoholic chemicals from a distance, as the vapors are carried in the surrounding atmosphere. As they are very volatile, they can easily catch fire. Gas cylinder. The gas cylinders are filled with liquid petroleum gas. The fuel is supplied from the cylinder to the burner because of the vapor pressure. The knob is used to close and open the valve to allow the gas vapors to pass to the burner. Drying. The drying is possible because of the evaporation of the liquids soaked in the wet objects. The heat energy from the surrounding is absorbed by these molecules of water. Due to this, the water molecules evaporate in the form of vapors, thus the vapor pressure comes into the scene. Exfoliations of rocks. The rocks are made up of different chemical components and do soak water molecules in them required for erosion for chemical weathering. These rocks, when exposed to the hot sun, the water molecules escape from the rocks in the form of vapors, thus resulting in the exfoliations of rock. Refrigeration. A frost is formed in the refrigerator. The temperature in the middle region of the refrigerator is cooler than on the surfaces, hence the cool air breeze from the middle to the surface of the refrigerator thus accumulates the water vapors at the surface and thus solidifies to form a frost, which is called false ice because it is made up from the condensed vapors. The food items or the water kept in the freezer will give out the vapor as the temperature inside the freezer is less compared to the heat energy present with these items. This heat energy is given off in the form of vapor. Fog. The fog during the winter season is formed due to the evaporation of vapors from the green leaves and from the water bodies as well. The vapor pressure formed in the foggy winter depends upon the density of the vapors in the region. If the density of the vapor is very high, then the vapor pressure in this region intensifies. Waterfalls. The waterfall is an example of the mechanical energy of the water, which is a combination of kinetic as well as the potential energy of the water. As the waterfall accompanies by the kinetic motion of the water, the molecules of the water associate the kinetic energy. This energy is given out from the volume of water and also due to the abrasion. These molecules escape from the water body and remain wandering in the surrounding atmosphere until it settles on the surrounding object or evaporates into the atmosphere at high altitudes. Air conditioners. As the air enters from the base of the machine, it runs through a pipe where the coolant liquid is circulating. This air is compressed by the compressor, due to which the gas turns into the vapor form, which is then run to the condenser to cool down the liquid, and then again the liquid is turned into the gas through the expansion valve. Frequently asked questions. How vapor pressure depends upon the heat enthalpy? The heat enthalpy is nothing but the heat energy required to break the bonds between the atoms. The heat enthalpy is very important for phase transition. A lot of heat energy is essential to break the bonds and convert liquid into the vapor state. The density of vapor will exert the vapor pressure in the surrounding area. What is meant by saturated vapor pressure? The saturated vapor pressure is the highest vapor pressure maintained by the liquid kept at that atmospheric condition. The saturation vapor pressure is achieved at the final boiling point of the liquid, above which the temperature of the liquid does not rise, and therefore the number of vapors formed at this temperature remains the same as the vapor on vaporization gets cooled down and condenses. Does the vapor pressure change with the rising volume of the liquid? The volume of the liquid does not affect its vapor pressure. The value of the vapor pressure remains the same whether you increase or decrease the volume of the liquid, but at the same temperature. At what temperature does the vapor pressure reach its equilibrium state? The vapor pressure is in an equilibrium state as the temperature of the liquid reaches the boiling point. At boiling point, more and more vapors formed get cool, giving away the heat energy in the surroundings, and then gets condensed, forming small liquid drop. Thus vapor pressure becomes equal to the atmospheric pressure. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.